Cool.
All right, so welcome again to the second general meeting of the Liquid Propulsion Group at Sacramento State. Let's first talk about my visit to the rocket project people. So, I'm gonna show you guys some pictures. This is their system. So, I went down there. I have a friend who knows some people who are part of the project, and we had a meeting. I talked to their airframe lead, their plumbing lead, and some of their hybrid people too. And we talked about their system. We talked about the hardware that they have laid out, and this is hardware that they actually test fired. And we also essentially got contacts to talk to them if we want to, when we start developing our own system, and we want to ask them for expert advice. We also got into a Slack that actually has all the collegiate rocketry teams in it. It has like USC, UCLA, UCSD, Purdue, Michigan State, MIT, like all these people who do collegiate rocketry, they're all in this Slack. And there's like this a lot of knowledge in that stuff, which is really cool. So let me tell you about the system. This is what they have laid out on the table. And before we go into it, let me show you what it actually does. So that, right, this is a picture that I took, and then this is them test firing it. Let's just watch it first. So yeah. They flew this system on, I don't actually remember if this is the specific system that they flew, but they have a flight system that they're using ethanol as their fuel and liquid oxygen as their oxidizer, and they launched it on an actual rocket. I think they got up to 30,000 feet or something like that. Let me tell you guys about the components. So if you remember, this is the fuel tank, this is the oxidizer tank, and this is their helium pressure tank. The helium pressure tank is what gives you the pressure to run the engine. This is their regulator, and then there's a bunch of, there's a check valve right here, there's pressure transducers. This is a AN fitting, which is something that the plumbing team is going to have to learn about. The AN fittings are a type of fitting that is very good for high pressure, low leak like applications. We'll talk more about that. You got closer up of the regulator. I think this regulator, they got an actuator right here that actually moves their valves. This is a ball valve. They got burst discs and a check valve. Burst discs are if something overpressurizes. The burst discs is a very thin piece of metal that will just blow out and depressurize the system really quickly. And then they got over here inside of their tank, so they have this aluminum tank that they made themselves, and rather they designed it themselves, and they had a third party make it for them. And then they have these skirts welded on it. This is for the airframe, but the tank itself, the pressure vessel, is here, and the dome's right here. You got the check valves again, and this is what their end caps look like. And this is the injector. This is pretty cool. So the injector they're using is called shower head injector, which means they put in fuel and oxidizer like this. So the oxidizer goes into this hole, and the fuel goes into this one. And then this is a pressure transducer. And then you got these holes. The bigger ones are the liquid oxygen holes, I think, and then the smaller ones are the ethanol holes. And with this design, you have some of them coming off at different angles, and the point of the injector is to impinge the fuel and the oxidizer streams onto themselves so they become gas and mix really fast, so you have really fast combustion. And that's something that we'll be designing. This is not the only way to make an injector, as you guys remember. There's pintle, and you can also do swirl injectors, but shower head injectors are pretty simple, and we might do them. Sorry, I think I kind of turned on the camera, and then I started talking all I got self-conscious, so I started talking all over. So hang on. Let's just chill for. I gotta chill out for a bit. Here we go. This is their propellant fill valve. This is where they load liquid oxygen through it. And yeah, that's mainly what I wanted to show. This is a graphite nozzle that they machined. This is a engine. So the engine actual like chamber, they put it inside of a tube, and then they put a blade of material inside it, which is something that will evaporate and cool the chamber walls. And then they also have a, oh yeah, this is a burst pressure vessel that they drew in ISO.
Is that broken?
Yeah.
Yes.
Yeah.
So burst. Well, now I just don't know where they are. Oh, okay. And this is a 3D printed engine that they made. So you take Inconel powder and then you 3D print it with selective laser sintering machine. And so this thing puts fuel in at the bottom and runs it up through channels to cool the engine, as we talked about. And then the injector goes up there. So yeah, that's kind of like my summary of the visit to UCLA. The most useful thing for us, thanks. The most useful thing for us is that we found people who are pursuing the same things and that are willing to share knowledge and that we can turn to if we want to advice on how to proceed, if we want to just talk about stuff. I think that's very useful for our goals. Next, we got Yarden talking about our Slack and the file management system that we'll be.
So this is not going to take much time at all. So the Slack and Drive is basically just how we're going to be able to communicate with each other. The Drive is going to is formatted so that each subsystem has its own drive. They're going to have research papers, diagrams, lectures, seminars, different places for you guys to go. The Drive will be shared after this presentation, so will the Slack. The Slack, I don't know how many of you guys have been on Slack. Slack is kind of divided into channels.
Everyone who's used Slack before?
Oh, so majority of you guys. So we will have our own channels and stuff. Everything's really in its early phases, so there might not be like a lot there. But the basic structure's there. We're still adding stuff to the Drive. I reached out to USC not too long ago, about like 2 weeks ago, 3 weeks ago, about some papers that they actually wrote and published, and I wanted to read them, but it said I had to pay $25 or $30 for each one. There was like 8. So I emailed them, they actually sent it to me for free, so I'm gonna upload that to the Drive so you guys have access to that and you guys can read it. The papers are really important for you guys to have a thorough understanding of whatever subsystem you guys want to be a part of. So say you're doing plumbing, the plumbing paper is gonna be the one you basically read. I would encourage you guys to read most, if not all, of the papers, as many as you can. I know you guys are busy. I know some of it may not be interesting to you. Like if you don't want to do programming, I would say just ignore the programming one. But for the most part, having a general like understanding and comprehension of all the systems will really help you maximize your abilities in yours and make your subsystem that much better. So for the basic, like the rest of the presentation is basically just gonna be Makar talking about the dungeon concept, because that's a CS thing, something I've never heard of. But it should help a lot with your comprehension, and it's gonna be a pretty engaging way for you guys to actually learn stuff and present to each other and present to us. So I'll get that all out to you guys after this meeting. If not, I might be adding some stuff tonight, so I may send it out tomorrow, but just expect it this weekend. Besides that, that's basically it. I think Makar's going to talk about the dungeons.
Cool. So yeah, the past couple of weeks, we met for the first time, right? And then we didn't really have anything to do for a while because I said, okay, we'll chill, I gotta get some stuff done, and then I'm gonna go to UCLA, and I know everyone was like, oh, when do we start? So sorry about that. This is what we're gonna start with first. The problem statement goes something like this. We're trying to build a very complex physical system, right? That has a lot of different subcomponents, that all has to work as one together, and that has a lot of complexity in it, right? So, and we have a big team, so, and we wanna, are you gonna close the door?
Yeah.
Thanks. We have to find a way to learn very, very quickly. in things that aren't, like, some things that are taught at, like, classes, but a lot of things that aren't taught as classes here, at least, right? And you want to expand that knowledge base as quickly as possible for the people. You want to share that information between each other so that people that are new to the club maybe, or people from another subsystem want to access the information that you gathered. So that can facilitate everyone's learning very quickly. And you also, the outside context problem is like, you don't know what you don't know, kind of. So if you have a procedural way of learning about stuff, you'll be able to more easily find out what it is that you actually should be searching for. So maybe like, if you were to try to find out what does it mean to make like a rocket engine? Like, how are we gonna make a rocket engine? You Google how to make a rocket engine. You get like YouTube videos about making like little candy rockets, right? We don't really know like what keywords to use. So that's the outside context problem. The context is outside of our current cognitive, knowledge base, right? So my solution that I want to try for this club is called a dungeon, and I believe this is an Intel thing. So I don't know if this is like all CS, but we're going to develop a procedural mechanism for seeking out unknown information together, individually or with teams. And we're going to establish a baseline meeting format that you can have with your sub team, so you can meet with them and pursue research in an effective way that is proceduralized. Anyway, here we go. FTFO dungeon. You've heard of GTFO, right? This is figure it the fuck out dungeon. Dungeon is a way to get a small group of people into a room. It's kind of